This video is for class 9 physics and we are doing the topic solid bodies with density rho greater than the density of the liquid rho L sink, while with the density rho less than the density of the liquid rho L float. This thing which you have already studied in class 7, we will try to understand how is this possible with the knowledge of upthrust. So let us start the topic. Let a body of volume V and density rho be immersed completely in a liquid of density rho L. The weight of the body acting downwards will be W equal to V rho G. As you all know, W should be equal to mass into acceleration due to gravity, but mass should be equal to volume multiplied by density. Hence, we can write W equals to V rho G, replacing this M by V rho here. Okay, and the maximum upthrust on the body acting right upwards will be FB dash. It will be FB dash, as you know, whose formula is also V rho G, but this time this density is for the liquid, this density is for the solid. Following three cases may arise. Number 1, if W is greater than FB dash, or I can write V rho G is greater than V rho LG. These were the formulas which we have just been introduced right in the above paragraph. Or this V and V gets cancelled because they are same, right? This G and G also gets cancelled because they are same, that is acceleration due to gravity. Hence I can write rho is greater than rho L. That means density of the solid is greater than the density of the liquid. The body should sink due to the net force W minus FB dash, which is also known as the apparent weight acting downwards. So we have already studied this case before when we started the chapter. So when W is more than FB dash, that means it should sink. Number 2, if W equals to FB dash, suppose W is equal to FB dash, the weight of the body is equal to the upthrust, then we can write V rho G is equal to V rho LG. So again V and V gets cancelled, G and G also gets cancelled. So what are we left with? We are left with these densities. So if the density of the solid is equal to the density of the liquid, then the body will float and the net force acting on the body should be 0. Remember, a floating object's apparent weight should be 0. That is the net force. Number 3, if W is less than FB dash, or I can write V rho G is less than V rho LG. Here also V and V should get cancelled, G and G should get cancelled. Hence I shall get the density of the solid less than the density of the liquid. The body will float due to the net force FB dash minus W. Here remember, the upthrust is more than the weight. So acting downwards, and only that much volume V of the body will be submerged inside the liquid, due to which the upthrust FB should be produced, which is also equal to small v rho Lg. So here what they are trying to tell us is that here the body can't be immersed completely. Why? Because if it is completely immersed, then the upthrust, that is Fb dash acting on the body, should be much more compared to the weight of the object. Now since it is more than the weight of the object, right, it cannot get fully submerged because the upthrust wins and the object will be pushed upwards, but some part gets submerged, that is small v. That's why the small upthrust, that is Fb, acts on the body, which should be equal to the weight of the object. So this upthrust now, not the total upthrust, this upthrust now balances the weight of the object, which is W. The net force on the body is still 0 in this situation also, because the floating object, it should not have any weight, the apparent weight should be 0. Thus a body of density rho sinks in a liquid of density rho L if density of the solid is more than the density of the liquid, while it floats in two cases: if the densities are same, or if the density of the solid is less than the density of the liquid. This can be demonstrated by the following experiments. So experiment number 1, take an iron nail and a piece of cork, both of same mass. First, place the iron nail on the surface of water containing a cup. The nail sinks. It implies that the force of gravity or the weight on the iron nail pulling it downwards is greater than the upthrust of water and the nail pushing it upwards. Now place the piece of cork on the surface of water. The cork floats. It means that the upthrust on the cork when fully immersed is more than the nail, because the density of water is more than the density of the cork, while the density of the water is less than the density of the nail. Okay, I hope you have understood the situation. This is a very simple situation here. The next experiment is take few solid bodies of different materials of known density and place them on the surface of water. It is observed that if the density of the material of the body is equal to or less than the density of water, right, in both the cases it should float, implying that the upthrust on the body due to the submerged part is equal, submerged part is equal to its own weight, that is Fb equals to W. Different bodies float on water with the different volumes inside water. If rho equals to rho W, that is if the density of the substance is equal to the density of water, the body floats with the whole of its volume inside the water, while if density of the solid is less than the density of water, the body floats with only that much volume inside the water, by which the upthrust Fb on the body balances its weight W. We have done the experiments on this topic also before when we started the chapter. On the other hand, if the density of the material of the body is more than the density of the water, that is, if the density of solid is more than the density of water, the body should sink, because the upthrust due to the water on the body is less than its weight. Now, this condition here. Now, thus the bodies of density greater than that of liquid sink in it, while the bodies of average density equal to or smaller than the density of the liquid should float on it. So, I hope this is clear. An empty tin can or iron ship floats on water because the average density is less than the density of water. Here, the average density of a hollow body is the ratio of the mass of the body equals to mass of the material of the body plus the mass of the enclosed air inside it to its total volume. As you all know, the density's formula is equal to mass of volume. Here, mass should be calculated for both the solid part and the hollow part, right? The hollow part contains air, and the total volume, right? So hence that kind of density where two materials are involved is known as average density, right? Okay, I hope you people have understood this portion. This much for this video. Thank you so much.